Again, I'm going to repeat that one more time. Imagine I have a general quadratic equation. In order to have a quadratic equation, there is a condition on this. Does anyone know that? A not equal to 0. Excellent. Because otherwise, if this is 0, then it becomes linear. Now, what's the solution for this quadratic and how do you, okay, let's go a step back. What's the discriminant for this quadratic? Excellent. When do you have exactly one real solution? When do you have exactly one real solutions? When you have two distinct solutions. When do you have no real solutions? Guys, you should know this. Okay, this means D equals 0. Okay, what is it here? Greater than 0. Excellent. And what is it here? Excellent. Now, if it's two distinct solutions, what are my solutions? Okay, it's a bit hard to write. I'll write it down. Minus b plus or minus square root of the discriminant divided by 2a. So every theory you need for this is in here. Literally all the theory part you need for these questions are in here. Now, let's do an example to see where is the questions. Oh, no. That's the equation question. Let's do an example to see if you actually understand this. Okay. So this is one type of question you can get from quadratic. They'll give you an equation, ask you, find the values for b for this has, some solution or something. Why is it given b is non-zero? Because they want this to be a quadratic equation. Not just because of that, but also if you put b is equal to 0 here, you get minus 1 equals 0. So the equation makes no sense. I forgot to mention this earlier, but that's why b non-zero has to happen here. Anyways, can someone tell me what does it mean to have, when I say has a solution, what's the condition on the discriminant? What do I put in here? Okay, I got d greater than 0. Okay, any other changes? Excellent. It's greater than or equal to 0. So I need you to understand has a solution means I have a pen. That means I have, maybe I have only one pen. I could have 500 pens. Both of the times I can say I have a pen. It doesn't mean I have exactly one pen. It doesn't mean I have more than one pen. It means I have at least one pen. So this is at least one solution. Okay, aside, what if it was at most one solution? What will be the condition on D? Okay, excellent. So they can play around with this is what I'm trying to say. So no, like if you get confused, think about it in English. Now, we'll do this question and then I'll give you a follow-up where, being linear or not comes into play. So let's do this. Let's find the discriminant. To find the discriminant, I need to know what's my A, I need to know what's my B, I need to know what's my C. So let's go back. Your B is the term before your X that comes with your X. So what's your big B here? What comes with the X? It's not just -2, it's -2B, okay? Everything that comes with X. Let's try that one more time. Your A is everything that comes with x squared. What's your A here? What comes with the x squared? Excellent. And your C is everything that comes with no x attached to it. Every term with no x attached. What's that? B minus 1. Excellent. So your discriminant is going to be b squared minus 4ac, which is minus 2b squared minus 4 times b minus 1. Which is going to be 4b squared minus 4b squared minus 4b, which is 4b. So here we want d greater than or equal to 0, which means I want 4b greater than or equal to 0, i.e. b greater than or equal to 0. But we are given what's special here? Look at this. We are told b is not equal to 0, so my final answer is b greater than 0. Hence, when b greater than 0, this thing has a solution. Any doubt in that? Again, you found the discriminant, you made it greater than or equal to 0, found the condition on b. There is no doubt. Question for you guys. Can this equation have exactly one solution? Is it possible for this equation to have exactly one solution? Exactly, no. If it had, let's say we have to find exactly one solution, that means d equals 0. So this has to equal 0, which means b equals 0. But this is not possible. So this equation cannot have exactly one solution. Okay, that has nothing to do with this question. That was just an additional question I asked. I'm going to give you a follow-up question. I'm going to make it up on the spot. So hopefully the question is not wrong. We're not solving the next one. I just want you guys to think about it. Again, if you have any doubts in the one we just did, you can ask me. If not, we're not going to solve this. I just want to know your approach to this. What would you do in this? First of all, any doubts in what we did before? We identify has a solution means at least one solution, which means discriminant greater than or equal to 0. We found the condition on B where that happens. That's it. There's a reason I'm asking this. What's different here? Anyone wants to say? Try, give it a go. So let's identify what is my big A, what's my big B, what's my big C. What's my big A? What comes with my X term? Okay, I don't know what people are answering here. So what's my big B? That's the thing that comes with X. That's 2 here. My big A comes with my X squared. That's A here. And my big C is everything that comes unattached to any X term. That's A minus 1. So I still have to do this part. I have to find b squared minus 4ac greater than or equal to 0. Solve. I'm not going to do it. And find the answer here, just like we did before. My question is, there's something else here that you can do. Can anyone see that? I did see someone briefly touch on that. So because of time, I'm going to give it to you guys. So thing is, this equation, exactly, there is nothing that's, A equals 1 is not special. Like A equals 1 doesn't mean anything here. But what happens if A equals 0? This is why I want you to keep in mind everything I did here. I can do discriminant and all that kind of stuff only if I know it's a quadratic. If I don't know if it's a quadratic, I can't use all this. So this is valid only if capital A is not equal to 0, i.e. here A is not equal to 0. Then it's a quadratic and I can do all this. But I don't know if this is a quadratic. What if A equals 0, then this equation becomes 2x plus minus 1 equals 0, i.e. 2x minus 1 equals 0. Which means x equals 1 by 2. So if A is 0, this is a linear equation which has a solution. If A equals 0, this is a linear equation with a solution. And this is the solution. So overall, if I asked you, when does this equation have a solution? I actually have two answers. One is if A equals 0, this becomes linear and gives me a solution. That has nothing to do with quadratic formula and all that. That's just understanding, this equation could become linear. Part 2 is everything we did before. Like if A is non-zero, this is a quadratic, we find the discriminant, blah, 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 solve like we did earlier. Okay, so final answer will be A equals 0 or whatever you get from here, fill it in. Does this make sense? Any doubts? I don't see anything because we are going to jump into AGM next. That's why I want to make sure there are no doubts. Any doubts? Again, big picture, think about quadratic formula and discriminant. That's applicable only if you know it's quadratic equation. So depending on the question, you might need to consider the case if it's not quadratic, i.e. if it's linear, what will happen, and when it's quadratic, what will happen. So be very careful when you do these questions. Any doubts? Does this make sense? The chat is just quiet. I don't know if it makes sense. If you have doubts, I have no idea what's happening. Okay, thank you guys. Okay, good. And the rest of it, I'll post it. This one I forgot to do the click here. I'm going to post it, okay? Let's go into AGM. Before we do AGM, let's do a brief review of AGM. Okay, AGM has two forms. Wait, did I get the side wrong? I got the side wrong. Which of this is the actual AGM that you can use at any point, any time you can use? Which one can you use anytime? First or second? Top, exactly. Keep that in mind. A lot of people forget this. The second one might be more helpful, but the second one you can only use if you know both of them are positive. If you don't know if they're both positive, don't use the second one. Okay, the first one you can always use. The second one only if you know they're positive. And also don't forget there is a condition, and equality holds. This is very important. If and only if x equals y. Do not forget this line in AGM. A lot of people forget this and make a lot of mistakes, okay? I.e. this inequality that you're seeing here, this thing becomes equal when x equals y. Like if and only if. When x equals y, it becomes equal, or when it becomes equal, it means x equals y. Okay? Now let's do this question. So AGM, there are two kind of questions we're going to do. We can do proofs, and we can also do min, and we can do maths. Okay, that's extra practice. So something I wanted to notice is this one is of the form sum bigger than or equal to product. Sum of two things is bigger than or equal to product of those two. Why am I saying this? This recognition of pattern is what helps you understand when to use AGM. For example, when I am asking you to find minimum, I can ask you to find minimum of a sum using AGM. I can ask you to find maximum of a product using AGM because of how the inequality works. Like I can find sum bigger than or equal to something, which means I can find minimum for a sum. For product, I can find maximum because I get product less than or equal to something. Okay. How do I know this is AGM? So again, keep in mind, AGM, sum of two things, product of the same two things. So here, I'm going to tell it to you guys how I found out. I see these two terms. Can someone tell me why these two terms are special? What's special about them? They're both squared, excellent. So I can say that 5 by y squared and 5y squared are perfect squares, which means they are both greater than 0. That's excellent. What's another thing that stands out or equal to 0? They're variables. What's something in relation to each other? What's special about them? Again, think in AGM. Sum of two things, product of two things. If I had to use AGM on these two terms, what's special? What happens? The products cancel out y. Excellent. So if you see a reciprocal, they're reciprocals in like when you talk about the variable, not entirely reciprocal, but the variables are reciprocals here. So whenever you see reciprocal of variables being added or some being added, huge hint that AGM is helpful there. Because when you have reciprocal of variables being added, you use AGM, you have to use product of those, they'll cancel out. And I'll show you what I mean. So let A be 5 by y squared, B be 5y squared. A and B are both greater than or equal to 0. So by AGM, A plus B by 2 greater than or equal to square root of AB, which means 5 by y squared plus 5y squared by 2 greater than or equal to 5 by y squared times 5y squared. So the y square and the y square will cancel here. That's what's special here. So you'll end up with 5 by y squared plus 5y squared by 2 greater than or equal to square root of 25, which is 5. In other words, you get 5 by y squared plus 5y squared bigger than or equal to 10. Does this make sense? Like when you use AGM, this is what I mean. Like when you have reciprocal of variables being added, huge hint to use AGM because then the variable gets cancelled when you do the product and you get a nice answer. Does this make sense so far? If it makes sense and I'm not seeing any questions, compare the equation I want and what I have. I don't want 5 by, yeah, go ahead, Taha. You can put it in the chat or you can unmute. Okay, while you're, I'm assuming you're typing your answer. So I'm going to talk while you do that, okay? So I don't want 5 by y squared plus 5y squared. I want 5 by y squared plus 10 plus 5y squared. So recognizing that all I need to do is add 10 both sides. Something I wanted to remind you, yes, Daha, and I'll show you another example of this. For this question, the bigger hint was find the minimum of a sum. That's what tells me it's AGM more than the reciprocal. When they ask you minimum of a sum or maximum of a product, that especially during quiz 1 where we didn't teach you any other way to do it, is probably AGM. But having a sum of a reciprocal and then you have to prove some inequality with that is a hint of AGM. Again, nothing in 102 is like 100% of the time. Nothing in math is 100% of the time. But at this stage of 102, when you're using inequalities with sum of reciprocals on one side, there's a huge chance it's AGM. It's just a tip. Okay. So when you add 10 both sides, you get this. Okay. And understanding that this extra constant of 10, I can ignore it until the last step, comes from practice. Okay. The more practice you do, you understand these kind of small tips. Like when I saw this question, I knew this 10, I can just add in the end. I don't have to worry about the 10. That I knew because I've done so many questions. This is why I'm saying understanding, then practice. Understand the concept, then practice. They both are needed for you to do that. Now, are we done? We are not done. We need to show 20 is actually attainable, i.e. 20 is actually a minimum. Because now I'm just saying everything, it's bigger than or equal to 20. Like, what if it's just bigger than? What if it actually doesn't hit 20? I need to actually show it can actually hit 20. Okay? i.e. I need to show this is possible. Because if it's not possible, then 20 is not the actual minimum. Minimum means I should be able to get this. How do I do that? I want this to be equal, which means I want this to be equal. I want this to be equal. I want this to be equal. And I want this to be equal. So I'm moving back. If I want the last equation to be an equal to, I go from back to front. Everything should have been an equal to. When can I get this equation to be an equality? Look at the board, like what we talked about AGM. When is AGM becoming an equal? Exactly. So when A equals B, equality holds. So let's try. So that means 5 by y square equals 5y square. This means y square equals 1 by y square. Y power 4 equals 1. Given y is positive, I don't know if you guys noticed, that was given to us here in the question. So this means y equals 1. Okay. So by AGM, when equality holds, i.e. A equals B, when we solve, we get y equals 1. This should be attainable and we can check. So when y equals 1, 5 by y square plus 5y square plus 10 becomes 5 plus 5 plus 10, which is 20. So this means 20 is the actual minimum. Does that make sense? Again, if we stopped here with that inequality, we are not done because that inequality just says the left-hand side is bigger than or equal to 20. But to say 20 is the minimum, we need to make sure we can actually get 20. So to get 20, we are like, okay, that inequality should have been equal. When how can that be equal? We move backwards, everything should have been equal. So we end up by saying, okay, we get 20 when the starting point was an equality. The starting point was AGM. When does AGM become an equality? We go back to the theorem of AGM. AGM equality holds if and only if x equals y, which is capital A and capital B here. So we solve for y using that equation. We found y equals 1 and then we check, is it true? We plug it back in and we saw when y equals 1, this equation does become 20. So we can actually get 20. So 20 is the actual minimum. Does this make sense? Yes, no? Again, you need to do the whole thing to get full marks. And if you want to do more practice for this, the extra practice questions has a slightly different but very similar, where I'm asking you to find the maximum of a product. Here we found the minimum of a sum. They're very similar but slightly different. Also, don't use calculus, guys. Last tutorial, someone said if they use like vertex or something, any calculus concept, you won't get mark in 102 because we are teaching you a different toolbox. So we don't want you to use calculus. Okay, if there is no doubt, I'm seeing. Okay. So do you want me to explain the green part or like why did I get the green part? Like which part do you want me to explain?
Yeah, can you re-explain the green part? I just like always get a bit confused with like when equality holds, especially when like you don't have a final value and you're just stuck with two variables. That's like something I'm a bit confused at with like some of the questions I've been through. So like,
So by the theorem of AGM, when A equals B, A plus B by 2 is equal to square root of AB. Why is that true? I'm not going to explain that now. This is explained in your textbook. So your textbook explains why this statement is true. So when we do
okay,
it here, I'm going to assume it's true. And if you want
okay,
more explanation on why that statement is true, I'm happy to do it in office hours. Okay.
okay,
That's something we take for granted here because that's
yeah,
the theorem part. And
okay.
is that the statement that you were confused about? Or is it the rest of it?
Yeah, I kind of understand like how you get the variable.
Mm-hmm.
Like it's just like I'm sometimes a bit confused when you have um two different variables, right? Like an
Like you have
example of
X
this,
and Y happening at
yeah,
the.
like so an example of this could be like, have you looked at the homework for 102?
Okay, how about we do something? Do you want to stay a bit after class and we can deal with that? Is that fine?
Yeah, yeah,
Few
that's
minutes?
perfect. Thank
Okay.
you.
No worries. Okay, let's come on to the next question then, and I'll end with this. So I want you all to look at question 3 and tell me, one, how do you know you want to do it by AGM? 2, what will your A be and what will your B be? Look at question 3. This is going to be homework. Question 2, I'll try to do. So question 3, how do you know it's AGM? What stands out to you? I said this for like 5 hours now. It looks very complicated. What's special about these terms? Exactly. The left-hand side is just adding reciprocals. So if you made this terms, A equals this and B equals this, and you use AGM, I'm going to let you do that. You're going to see you're done. That's it. Literally put A equals this, B equals this, do AGM, and you're done. Again, how did I know that? Because I see complicated things, but the variables are just reciprocals. So if I see complicated variable reciprocals being added and I have to do an inequality question, huge hint, it's AGM. Okay. Now part 2, again, AGM, I'm going to remind you, you're going to look for the sum of two things and the product of those. This is the AGM format. Your goal is to find the two terms when you do an AGM inequality. So look at the question, identify the sum and the product, and your goal is to find what are the two terms. So let's do this question, and I won't do the proof and everything. I just want you to identify the terms. So the question is 4b squared plus b plus 1 divided by 4 absolute value b greater than or equal to square root of b plus 1. I'm telling you it's AGM. So you could do, maybe there are ways to do it without AGM, but if you are doing it in AGM, your goal is to find the sum of the two things in the product. So what are those two terms? Can anyone see a pattern here? Do you see a sum of things here? You don't need cases. You could. You don't need them. Let me give you a hint. In 102, you learned this. This is such a fundamental thing in mathematics. So, by the way, this is all going to be rough work. So I'm going to rewrite it like this. Now do you see it a bit better? Okay, I'm going to give a hint because of time. What is one term that you can see there is a part of a sum and it can be a part of a product? It's very obvious here. There is one term that comes in the both left and right hand side. Yeah, b plus 1. It's here and it's here. So that's a big hint. That's probably the one of the terms. These two are what like stumps me. But when I rewrote it as b square, it like did it for a reason. So what if I did this? I can now rewrite it as like that. Do you see the product and the sum appearing? So all I did is like I took the denominator to the other side. So I'm going to rewrite it a bit more. Do you see the sum and the product now? All I did is rewrite the question. I didn't do anything else. Why am I doing this? It's to get the AGM terms, because now I know my AGM terms. This is going to be my A. This is going to be my B, because I have A plus B on the left side and AB on the right side. Again, how did I know this is what I should do? Because that's the question here, right? So again, at this point, there isn't much tools we have given you. So maybe there is a way to do this using rough work without AGM. Go ahead. But once I decided I wanted to do AGM, my brain is like, okay, I want to know sum of two things bigger than product of two things. And I want to identify those two things. First thing that stands out to me, I can find B plus 1 on the right and left. So I decide, okay, B plus 1 is probably going to be one of them. That's the first hint. Then I have a B square and an absolute value of B. Can I relate them? So this is where the knowledge from 102 comes in. You should know in 102 there is a way to relate B square and absolute value. I use that. And then I'm like, okay, I do have the sum of two things. I don't see the product of two things. How do I ensure that happens? Simple solution. I have a thing in the denominator. I take it to the other side. Suddenly, voila, I get a product. And then it's just a small manipulation to get the constants right. Okay. So always keep in mind, what are you looking for? Again, if for the first time you're doing all this during a quiz, it might not be enough time for you to come up with this. This is where practice will help you a lot. The more practice you do, the easier you notice these patterns. Now, I'm going to post the slides afterwards, because it was like online or not everyone knew. Usually after tutorial, I will post solutions for things we didn't do in class. If we did it in class, I will not post the solution. I won't post the annotated slides. Today I will, just because it is online. It's a bit weird format that we didn't expect. And at the end, I also have a thing called extra practice stuff. And I post separate solutions for that towards before your quiz, but not immediately. So you get some time to work on it yourself. And then I can post it. Okay. So a lot of practice for you, a lot of things to work on. If you have any questions, you can ask me. I'm going to stay on for a few more minutes. One of you already had a question. If not, you can come to office hours on Friday, or I'll see you all next week. Good luck on your quiz and homework. Don't stress out. You got this. Any questions? Okay, and somebody had a homework question. You can ask that.
Oh, do you think you can pull up the homework?
I am opening it right now. Give me a few.
Okay, it's just it's question. I think it's question 4.